Hey, what's up guys, my name is the Cherno. Just gonna have a good drink. And welcome back to the Game Engine series. So, how is everyone today? Vague Lobster, tier 3 sub, 31 months. Amazing support, thank you so much. Also, Griush, thank you for the Prime sub for 17 months as well. Really appreciate the support, guys. Alright, so today I'm still buzzing about being mentioned by name in your I Am GUI Vulkan video. Did I mention you? Game Coder NZ. Don't remember that. I Am GUI Vulkan video. What the heck's that? Like, do you mean like the one I made like a year ago? Oh, Sean Nolan. Ah, you're talking about the Genesis, like the recent one. Yeah, okay. Yeah, nah. Solid comment. That definitely got me to, like, if I probably wouldn't even have tried to upgrade IMGUI, to be honest, to check if they solved the whole sampler situation. Worked on my machine, yeah. Alright guys, so last time we basically rendered like somewhat of a font like atlas. Those of you who have no idea what we're doing, we're working on like font rendering, text rendering. And we're using a library called MSDF Gen, and MSDF Gen Atlas, or MSDF Atlas. MSDF Atlas Gen. So much stuff. Oh my stupid, I should get that to start with Windows. My little drawing tool, which is called Zoom It, for those of you who don't know. So I can do this, and this, very exciting. Yeah, so this was the like font atlas that we generate. So this is like from the Open Sans font that we load, and we basically like whatever. I'm gonna give up on that. And basically what we do is we ask it to generate basically every character in the Latin kind of set of characters, and you can kind of see all of them here, right? They're all kind of packed, so that's why you can see they're almost like sorted by. It almost looks like they're sorted by height. So like these guys, this is like this character over here has like the lowest height, if that makes sense. Like the Y range of that is like very small. It's like 4 pixels or something. Whereas this guy is the tallest, right? So you can kind of see that it's like, it's almost sorted by height here. And you kind of get all the smaller characters here. And then as you go up, it's like bigger characters. And then we have like all of it. So basically my point is it's not like in order. So if you look at this and you're like, oh, I didn't see A, B, C, D, E, F, F, G. Like I didn't even see the English characters. They're here. You just kind of have to look for them. So like, well, these are capital. Like, this is capital A and B, for example. But if we find like, here's a lowercase a, like what, A, B. Where's the lowercase b? Here's a lowercase b. You guys can kind of get the point. Like they're all here. They're just kind of in random order. Now, the thing with this though, is that for some reason, like what I'm seeing here is obviously not like a signed distance field. Like they should look colorful. I'll show you what they look like in a minute. But this clearly like is not really correct. What we're seeing here, what it looks like to me is just some kind of like anti-aliased, like kind of, you know, rasterized font glyphs into pixels, right? With some anti-aliasing. Like that's what this is, right? Whereas what it should look like, stupid little fan thing. Sorry, I got this like pop-up for fan speeds that pops up on my computer. It's really annoying. MSDF Gen. So, and where's the Atlas Gen actually? Or MSD, is it? Atlas Gen. Yeah, this is what I'm expecting to see, right? Something that looks like this. So you can see there's quite a difference. You can still see all the characters clearly, but the colors actually kind of indicate the like assigned distance field for that specific edge, if that makes sense. Like it kind of shows you like, you know, not just the character, but which way it kind of expands in. And that can be used to easily scale up and down all that stuff. So yeah, so see, this is kind of what it should look like. Whereas what we're seeing is kind of like this, I guess, right? So somehow we managed to not produce this, which I think is what we asked for. Because I don't think we wanted the MTSDF. I think we just wanted MSDF with 3 channels, not 4. But we ended up getting like this. Yeah, with like the anti-aliasing and whatever. And this is just a normal sign distance field, which gives you scaling, but then this is a bit better because I think you can still have sharp corners. Because what can happen with normal normal sign distance fields is that like the letter A might start looking like that because it doesn't really support the sharp corners that you might want. I don't really know the details, to be completely honest. I'm not like an expert on this. I just make it work. Very thirsty. I just had like a bunch of pizza. My wife and I did like a little Valentine's Day today instead of tomorrow. So that's why I'm recovering from a food coma. But it's okay. The game engine series must go on. I did briefly consider canceling the stream, but kind of felt bad for you guys, to be completely honest, because I feel like I've been pretty loose on the live streams this year, and I promised February would be like the beginning, so here we are. What pizza? We had 2 pizzas. It was like a margarita and a supreme with like everything on it, which is fun. I don't know, you gotta have the margarita there. Like, classic margarita pizza is just so good. Like, people underestimate that. People think like, oh, you need the lots of toppings. Like, nah, a good margarita, that really hits. All right, anyway, enough about pizza. So yeah, so why aren't we generating this guy? Like, that's what we need to kind of work out. So if we look at our font.cpp and we go down to like, so create and cache atlas, looks like we use MSDF, like we actually specify which generator to use, as well as like the number of channels, I think is what N is. And if we take a look at this, like we are clearly asking for like the gen function inside immediate atlas generator. Like it looks like we're generating the right thing. The texture format is RGB8, which is, I guess, correct. The data seems to be like set correctly. I mean, with the obviously data is being set, otherwise we wouldn't see anything at all. So like, yeah, I don't know, man. I don't know why this isn't working. MSDF generator generates a multi-channel signed distance field of the glyph. That's exactly what we did. And it takes in like a bitmap ref 3 for the output, which is what this is, right? Oh, well, actually, we pass this into immediate atlas generator. There's that gen function, generator function. Where's that used? Yeah, I think. Yeah, here it is. So it calls it with like the glyph bitmap and all of that stuff. I mean, yeah, like it seems like it's trying to use the correct one. So we might have to debug this and see like what's going on. Let's just run this. I guess generate. So let's see like what it does. Let's go to this gen function and see which one it steps into. MSDF generator. Okay, so it's definitely MSDF generator, right? Scanline passes true. Okay. Generate MSDF. This is very weird. This is all weird as well. Can we go into, whoops, I stepped out. Maybe I can step into this. It's a little bit annoying because there's like, to do this, it spins up like 8 threads. So the debugging is kind of all over the place, by the way. if you go to debug and parallel staxies, here we are, then you can kind of see maybe if it's still going. Well, that's the finished parallel. You can kind of see well, here's one thread generating it. Here's another one. But yeah, it looks like it's doing that. Well, yeah, I mean, it looks like it's obviously generating an MSDF. So what's your problem? Like, why is that not working? Did I see what Faceless Tiger wrote? You just forgot to call edge coloring on the glyphs, I think. I forgot to call edge coloring on the glyphs. What was I supposed to do that? How? What's the difference? Like, as in, how can you have that without edge coloring? Doesn't that not make sense? I'm just gonna quickly check Big Hazel. But yeah, maybe that's the problem. I mean, it sounds like it might be. So you need to do the whole edge coloring thing, do you? Isn't that just supposed to generate it with that, or do you have to like do that for? I guess you do have to do that for. That's a bit annoying, but sure, okay. Let's do that. So basically, if it's like MSDF, if we do MSDF or MTSDF, then we need to. There's two ways to do the edge coloring, and you have to do it for each glyph. Apparently there's expensive coloring, and there's not. Well, I don't know what the difference is, but whatever. The heck is all this stuff? Again, this is like, I'm copying this from Big Hazel, but Big Hazel, like I wrote it for Big Hazel, obviously. I copied it from the command line application that comes with MSDF Atlas Gen. So MSDF Atlas Gen actually has, it's probably not included in here, but if we go show all files, we'll probably find it here. Just so that this doesn't seem like magic. Where was it? Oh no, so it wouldn't be in here. It would be in here, I guess. But that is all here. Main. Okay, apparently it is here. Alright, it's just macroed out. Yeah, so you can see there's a file called main.cpp inside MSDF Atlas Gen, and that has all this stuff such as, you know, edge coloring, right? So, yeah, you can see here that if we're using MSDF or MTSDF, then there's two ways we can do basically edge coloring. There's expensive coloring or not. So let's just copy this actually since we're here. We'll paste it like here. And then also you can see this uses this thing called LCG multiplier, which is defined to this. So let's grab that. I don't know if we need the increment. Yeah, we do. So let's just pop that here for now. Let's do false here for now. And then yeah, there's this other stuff here as well, like workload, which is actually inside MSDF Atlas Gen. So we just need to add MSDF Atlas namespace to that. That should be okay. Now the glyphs are... Where did we store the glyphs? Did we even load the glyphs? So edge coloring, I imagine, creates the actual... See how like the edges here are colored? And they're colored like they're basically what they are is they contain more detail on how like the glyph is actually shaped, like vectorally. So that just means that because we have that information, we can kind of extrapolate the edges in the correct direction. And that means that we kind of, like, the most important part, I think, well, I would say, is that we gain scalability. So usually if you have like just, you know, rasterized pixels like you would see here or here, if you try and scale them up, they're obviously just going to look blurry, like, you know, like this, because they're already rasterized pixels. But by having assigned distance fields, we can kind of, you know, because we mathematically, I guess, maintain the information of how the glyphs are actually rendered, it means that we can scale them up to any size, and then it's almost like we're rasterizing them on the fly. Not quite, obviously, because we're not literally rasterizing them from vector math, you know, to pixels on the fly, like in a way. I mean, we are rasterizing as part of like rendering the quads in the fragment shader, but it's not like constructing the glyph from scratch. It's just in kind of a format that still retains some of the information of the original glyph, but then also is somewhat rasterized to make it easier and faster to render than just like completely if you were rendering it from like a vector format live. So that's kind of like the deal. Maybe someone can explain it better than I can though. Need some more water in a minute. That pizza has made me thirsty. I feel like I don't have pizza that often, but when I do, like, I just feel like, you know, you want a good binge. Not that, like, I don't know. I feel like two large pizzas between two people, like, is that a binge? We didn't finish it either, which is usually save leftovers, but still, like, I do feel like it's definitely more than we need. But it's nice. All right, so yeah, anyway, back to this. So, glyphs and config. Yeah, so glyphs. So where do the glyphs come from? Glyphs are MSDF data glyphs, yeah. So like, because we have glyphs, here they are, right? So we can capture them just by doing this. And then config, I don't think we need config. I mean, we do use coloring seed and stuff, which actually I kind of retained. But I don't know if we need that. What's that initially set to anyway? Nothing. What? Legitimately does not look initialized. Nah. It's just like some seed. Thread count. Well, thread count, we kind of... said was 8, but we'll probably end up refactoring a bit of this stuff later. Glyphs. Is this... Yeah, what is this coloring seed? So coloring seed seems to be this unsigned long here that I guess you can pass in a seed. Is there a default value? Doesn't really look like there is. Well, I guess it's maybe just 0 or something. Let's just set it to 0. An unsigned long. So a uint64t. And then we can capture that by reference. Config.edge coloring. What the heck's that? Oh, it's a function. Wait, is it? I mean, I guess so. Yeah, so where's that set? Okay, so MSDF gen edge coloring ink trap. Why not just like do that. Angle threshold. Default angle threshold. Sounds good. And what's that? 3. There's so much to this. Why are you upset? Oh, because that's outside of the lambda. I don't know if this is inside Atlas. Yeah, it is. All right, no more errors. Is that it? I guess so. So now the glyphs apparently have edge coloring. So let's see if this works now. Oh, hello, Yuri Kurai. Kurai. I feel like I'm getting worse at these names. Getting old. Hey. Alright. Well, that was easy. Solved. See, now we have these beautiful characters. So, yeah, I guess let's try and render them, right? Fan of Cherno, thank you for the sub. 23 months. Tier 1, appreciate it. Fan of Cherno is always there. Always there for me in the stream. Characters. So, yeah. I guess we could try rendering something. That'd be kind of nice. Let's try rendering, like, I don't know, Cherno or something. That sounds nice. Well, maybe let's just start with one character. So MSDF Gen actually provides, I believe, an example. So if we go to MSDF Gen, there's like a nice little example of using it, right? So here's an example of a GLSL fragment shader with anti-aliasing. So we actually have a really easy example we can just copy. And you can see that, like, here's the texture coordinate into the atlas. We have the output color. So that's what we're outputting, obviously, over here. We have the MSDF atlas as a texture here. And then we have two, well, they've written as uniforms. So 2 uniforms for background and a foreground color. And then basically you just use these couple functions, which, yeah, and then screen px range is a function they call here, which I guess needs to be implemented somehow. Oh, here's a sample one. Yeah, that's it. So we could just try this, but the thing is, to get this to work, obviously, the important thing is we kind of need to know this texture coord situation, right? Because here we're sampling from the MSDF texture atlas, which is that whole texture. It's a single texture, you know, that has all of the kind of glyphs that we need, right? So we still need to have a texture coord, and if we want to render it in like as one character, which is what we're going to want to do at a time, then we're going to have to obviously know like the texture coordinates of that like character. So that we need to work out. So let's have a look at how we can do that. I think, like, again, I'm gonna kind of just look quickly at Hazel, Big Hazel. Oh, excuse me. Where would this be? Render a 2D. That does the fun stuff. Right, so font geometry get glyph, and then we can do some get quad plane bounds or whatever. This is moderately complicated from what I can remember. But we'll see what we can do. So apparently we need font geometry and metrics, which is actually inside font geometry. Okay. So can we get we can get MSDF data Okay, well, let's go to render a 2D. Which we should somewhat refactor. Let's make a static void drawString, which is going to take in, let's just make it take in a string. Well, like, we're going to want it to take in probably a font. So here we take a transform. Let's take in like a color. Yeah, I guess we could take a transform. And what happens to that transform? Yep, let's do a transform as well. Okay, that should be enough for now. Okay, and then, so we need to, from the font, let's say font geometry. So that should be, we need to get the MSDF data, and then we need to, wait, how do we, where do we implement that? Okay, so MSDF data, I believe, is implemented in CPP. So that's not really gonna fly anymore, because obviously we need to access like that data probably inside the renderer. So it depends again how you want to how you want to make this work, because you could easily just you could make your own almost wrapper around this, like kind of like an API, just to be able to provide yourself with all of the necessary metrics that you need in order to render, or you could just get MSDF, you know, to do that for you. So I don't know. Like, there's a lot of stuff in MSDF that like might not be necessary. But I also don't know if abstracting it away like that is also a good idea, because there's just a lot of extra work for really not much benefit. So I feel like that's not the best idea. So what we're gonna do is we're gonna grab MSDF data. We're gonna basically chuck it in its own file. So I'm gonna make a new item here, a header file. When it loads the stupid templates, what the heck's going on? Oof, I'm coming down with that food coma now, guys. Come on. This is not helping. Like, okay, there we go. So MSDF, we'll call this MSDF data. We'll obviously namespace Hazel, and we'll paste that in. We'll have to include like, you know, vector, and we'll have to include basically this. So we'll undef infinite and include that. So we have this now here, and we'll include that obviously in here because we need it. And then now what we can do is obviously include it in renderer 2d.cpp as well, which just gives us access to a function that we haven't written yet that's going to return this. I don't know if this needs to be const. Like, either is fine because we're just copying the value of the pointer, but I'm more just thinking about technically what it should be. I guess that's fine. So if we do that, then we'll get the font geometry, And then we can also do const order font or just metrics equals font geometry get metrics. So this is now already inside the MSDF API, right? And then in the metrics, it's going to basically contain kind of everything we need. So, like, unfortunately, when I wrote this in Hazel, I kind of wrote it like, excuse me. I kind of wrote it as like a first pass thing, and then I just never changed it, which was a bit, like, upsetting. I kind of wish I put in the work then, but so it's pretty rough, which is a bit unfortunate, but it works. It's just a bit not as clean as it probably could be. So basically, here's the couple. Here's the I don't know why these are even doubles, but here's the way it works at the moment. So apparently we have 1 divided by metrics dot ascender y minus metrics dot descender y. So font metrics, like I've talked about this before, but font metrics are like, there's quite a lot to them. And there's some good web pages that kind of talk about how this stuff works and what all the terminology is. So like, you know, FreeType actually has a bunch of good like diagrams here that just, you know, kind of talk about like what, say, xmin, xmax is, like what, you know, certain bearings are, what is an advance, you know, that means like that's how much you advance to before you draw the next glyph. Like there's all this like different terminology here. Ascender is like, I don't know if that's, yeah, see, like scaling the font ascent or descent, like, so that's like the distance from the baseline to the highest or upper grid coordinate, and descent is the lowest grid coordinate. So as far as I understand, that's like, if we go back to that diagram, and yeah, you can kind of see this all here. So this is like the baseline, and then I think the ascent is like this distance, and then the descent is like this distance, right? So you have the descent, and you have the ascent. And this is kind of like, you know, to the, I guess, to this portion, and this is down to this portion. Because obviously, like, you have a section above, a section below, and even though you're kind of drawing it from the baseline, you know, when you're actually creating a quad and positioning that quad in like 3D or 2D space, it has to be like, obviously like this. Right, and this might be like, you know, 2 triangles. And then you have to also fetch the right texture coordinates. And like, then you also have to make sure you advance the right amount to draw the next quad for whatever character that might be at the correct, like, advance, right? So yeah, there's a lot to it. Isn't that the bearing? Yeah, it kind of looks like the bearing, doesn't it? Bearing Y and bearing... Well, that's bearing Y and bearing X. But see, bearing X is from the, like, vertical kind of... So this is like the 0, 0 coordinate. This is like your cursor position or your pen or whatever. And I guess bearing is the amount you move forward, and bearing Y is the amount you move up. But I think that's like the same as the ascent, no? From the baseline to the highest or upper grid coordinate used in place of an outline point. Yeah, I don't know. And the topside bearing is the vertical distance from the baseline to the top of the glyph's bounding box. Usually positive for horizontal layouts and negative for vertical layouts. In FreeTypes, it's called bearing Y. Ascent and descent are for the biggest glyph. Ah. Oh, right. This is for all glyphs in a given font. That's why. Okay, gotcha. Thanks, Builder Vanished. That was helpful. Alright, so so what do I have next? Yeah, and like I'm gonna just write this out a little bit as like how it's written in Big Hazel, and then we might fix some stuff. Like again, I still don't understand why I decided to go with doubles. That's probably part of what their example used, and then because eventually we're into this as floats anyway, but like maybe it's nicer to do the math with more precision. I highly doubt it, but sure. Oh, that's irrelevant. All right, so okay, so let's get the character now. So what I actually do in Big Hazel is we actually convert it from an std string, which is UTF-8, to a std-u32 string, which is like UTF-32. The reason why we do that is because then we can just treat every character as a char32t. So we kind of almost decode it from Unicode, or from like UTF-8, which is variable length encoding, into like a fixed length encoding, which is 4 bytes per character, which is what this is. And then, well, yeah, that just means we can obviously support like more languages, more characters, all of that stuff. And it's easier for us to render, basically. So, I'm not going to bother with that, I think, at the moment, because I also kind of want to think about that maybe more. But basically, like, let's just try and get a glyph. So let's just try and render, like, you know, well, we could obviously go through, we could loop through it, every character in the string. But for now, let's just say that what we are trying to render, character, right, is like the letter C for Cherno, obviously. So if we do glyph, we can do font geometry get glyph, and then we basically just pass in the character. So here we are rendering C. We have the glyph, which, what is this? It's a const MSDF atlas glyph geometry pointer. So we have glyph geometry now, basically. Now, if that returns null, then it means it could not find a glyph for this character, which is possible, obviously, like if you, I don't know, are using a font that doesn't have a certain character. So like, usually, I don't know, I don't think this comes up too often, but like, you know, frequently if I'm trying to, I don't know, write some Russian or whatever, like lots of fonts don't have that. So you probably want to handle that and maybe just do something like, well, if it couldn't find the glyph, then let's maybe fetch something else, such as like, I think Hazel fetches a question mark, right? So you get kind of like a question mark. So that's something you could easily do. And finally, if there's no question mark, well, in Hazel we just continue because this is in the context of a for loop looping through this. But here we could just like return or whatever. But the point is that's obviously a big failure because why do you not have a question mark? That's our failed character thing. So next up, let's grab, so we have to calculate the geometry apparently. But yeah, so we can do that by basically calling a function called get quad plane bounds, and see there's basically it outputs like 4 doubles here, right? Left, bottom, right, top. So we can do like plane left, plane bottom, plane right, plane top. And I think that's the right order. Yep. And then we basically have a quad min. We basically have a min and max now. So, and here I'm casting it to floats. So we have our plane bottom, our plane left and bottom. So this is like the X minimum and the Y minimum. And then we're going to have the X maximum, which is obviously plane right, and plane top is the Y maximum. Now we then have to scale this by the FS scale, which is defined up here, for both min and max. And then we offset it. It's almost like a little scale bias. We offset it by glm vec2 x and y, which I actually don't know what that is. We haven't defined that yet. Lol. Or have we? Oh, we have. So x is 0. Yeah, so this is kind of like your font advance, right? So of course we're going to start at 0 basically. That's going to be like where we start. And by the way, this will all be kind of transformed later. So we have a transform up here. You guys can't really see that because of the face cam, but we have a transform up here that's eventually going to be transformed. But it's kind of like we're doing this in local space, and then we're going to multiply each vertex by the transform probably before we send it to the GPU. Or we could send the transform to the GPU and do the multiplying there, but that's going to be probably not worth it. Okay, so yeah, so that's that. And then of course we need some other things here. Although, what is this even? Maybe that was a weird thing to do, actually. Yeah, that doesn't look quite right. I looked at the wrong branch. I don't know what the other branch was. Oh, this is for maybe vertical text? I don't know. Let's do something else. Let's do this instead. So instead of this, what I'm gonna do Y is I think maybe when I was first writing this, I couldn't decide if I wanted to go from top to bottom or from bottom to top, and then I decided to do from bottom to top instead. So that means Y is 0 because we're kind of, that's like the baseline or whatever. This is still correct, I believe, yeah. Blah, blah, blah. Yeah, so what we'll do is we'll get the quad plane. I don't think we do this quad min and max stuff, or at least not for now. But we do two things. So we'll do the quad plane bounds, but then we're also going to do the atlas bounds, which I believe are basically the texture coordinates. So I'm just going to do AL, AB for atlas bounds, AR and AT. So that's the quad atlas bounds. We've got the plane bounds. And then we're gonna basically multiply. So basically what I'm doing is I'm multiplying. I'm kind of doing the same as I'm doing here. I'm just not calling them this for some reason. So I'm doing like basically all of these like get multiplied by scale, which, yeah, we'll see if we end up changing this later. And then also we add to them X and Y. So obviously to the to these guys we add X, to left and right we add X, to the vertical ones we add Y. Okay, then we have to figure out the text cell width, which is going to be 1. Again, I don't know why that's a double. That's going to be 1 divided by the... Oh, we need the texture for the font atlas. So text cell width and text cell height are basically just going to be the size of each text cell, which is basically going to be the size of, like, each... It's almost like the size of each pixel, right? Because, well, not really, but, like... So, we have a texture, right? It might be 512 by 512. I think our one is at the moment. But we obviously don't, like, refer to the coordinates by their pixels. We refer to the coordinates between 0 and 1. So if we have 512 pixels, what is the size of each pixel? 1 pixel. But if it's 0 to 1 instead of 0 to 511, then how big is a pixel? And we do that by just, obviously figuring out like 1 divided by the width and 1 divided by the height gives us, some 0.00 whatever, which accounts for 1 pixel inside this thing. And we need to know that. So let's get the font Atlas, which is going to be obviously in the font. So we'll do get Atlas texture. And we can do width and height. And then we're going to take these Atlas bounds or whatever and multiply them apparently with texel width. It's the same as like this, but yeah. Which one haven't we done? Top. All right. Cool. So that I believe is kind of it, and we don't need this. So now that we have this, which again I might rewrite later. We can basically draw now something. So if we go to, the thing is, we're gonna have to set up, like in order to get this to work properly, we're gonna have to actually set up something. Like we're gonna have to set up, like I don't want this to go through quads. We're gonna have to probably set up, you know how we have like quads, circles, lines? I'm probably gonna make another one for text. So I think I wanna do that next time, but because I do kind of want to see, I guess we probably should wrap it up here, to be honest, because there is quite a lot of work to do in order to actually see something. And I don't want to, like, what's the point of like half doing it, like, and doing it not properly. But this is basically it. So basically the idea is now we have our geometry, right, which is what this PL and like this stuff, this PL, PB, which I guess let's rewrite this a little bit, just because I get that there's 4 here for some reason, but let's rewrite this so that instead what we have is, let's just write this as like, I think I'd write this as GLM vec2 atlas, well, this is the texture coordinates, right? So we could say text coord min and text coord max, maybe. But see, the problem is, I guess these are not, how did I get the other ones to work? Because these are not doubles. So I guess we'd still have to extract them as doubles, because that's how this API works. And then we could say text coord min, for example, would be like AL and AR. No. AL and AB. And text coord max would be AR and AT. So basically what this is the text coord min is like this guy down here, and then the text coord max is this guy up here. So you kind of have your min and your max for your texture coordinates. And then for the plane, it's exactly the same thing. So I'll say quad min and max. And that's obviously just P instead of A, basically. And then instead of like doing all of this stuff, if we wanted to, I mean, we can just still do that, but see, this becomes way easier as well, because like, well, it's not way easier, it's just written as one operation rather than 2, but it's still kind of doing it 2 internally. So what's this? This is for the quads, right? So because here all we have to do is quad min times fs scale and a quad max times fs scale. So that's scaling that. And then we do the kind of offset, which we can just do as like quad min plus equals xy and xy, right? And then we also have to do this once we have the textile height stuff. So that's going to be texture coordinate min times equals textile width, textile height, and max, right? So I guess that's a bit cleaner, right? I don't know if it's like, would be a better idea to cache some of this. Maybe, probably. But that's what we can do for now. Yeah. And then once we finish rendering that glyph, so render here, and then what we can do is we can actually get the advance of the glyph, but I think that needs to be done contextually as part of like this string or something. So basically you have to then do font geometry, get advance, you pass in that advance, which does that? I don't know, maybe that's what I've got written here. You pass in the current character, you pass in the next character, which let's just say is another C for now. And then that will get you, that will write into this advance. And so now you have the new advance, and then you can just do like x plus equals fs scale times advance. And then I have a, like in Hazel, you can define a kerning offset, which I'll just write as 0. But that's just like, so what you can do is like, that's just going to be an offset so that you can basically have tracking for your characters. So you can space them out. So instead of like being Cherno or whatever, you can make it look like this, right? You can space them out. And so that's what that is. You can just add an offset. Yeah, like lots of stuff, right? But like, I'm serious. Like, this is just to render basically like one character. Well, I mean, this can be used to render more than one character, but like the idea is this is just to render like basic text, but then you also want to be able to deal with, for example, like things like new lines. So if you have a \n in your string, then maybe you want to drop to the next line. Or what if instead you have some constraints? So maybe you have like a panel that's this big. Well, you want to just provide a string of text and you want it to automatically sort it out into separate lines, right? There's all of this complexity that comes. Or what if this is an even harder problem to solve? What if you want to fill a space with text? So you have a space that big and you want to fill it with text, meaning you dynamically choose a font size based on how much available space there is. That is basically, as far as I'm aware, that's impossible. And the way you do that is by trial and error, meaning you literally try a font size, then you like double it, and then you either do like a binary search type deal, or you narrow it down to like, okay, this fits, done. Like, it's not easy. I don't know, maybe there's a better way, but that's how I know it to work. So there's like, and of course you can cache it once you figure out what the answer is, but yeah, there's lots of stuff. Yeah, like text wrapping, like, yeah, lots of whatever. Need to put in Chromium just for text rendering. Yeah, like legitimately though. Your channel served as a perfect copy pasta for half my comp sci class during 3D rendering. I just finally see you stream. You're welcome. You're welcome. All right. Anyway, guys, I'm going to wrap it up today because I'm food comaing and also I'm very tired, and also there's quite a lot of work to get onto the next stage, which is going to be actually rendering stuff using this texture that we've got now. So now we've got the proper MSDF texture, we've got the proper font metrics. Now we just need to slap on some quads, basically render them batched together, obviously, as we currently are with our renderer 2D, which is batched already, but we need to basically run it through a custom pipeline because we need a separate shader for that. But yeah, next week we should definitely see, hopefully not just one character being properly rendered on the screen, but like an entire string. So very exciting. But thank you guys for watching. Hope you enjoy the rest of your day, and I will see you next time. Goodbye.